So the exercise that we just did, basically we're just going to recap this quickly. So the exercise that we just did, we just proved that having square is going to maximize the area, right? A square shape. Will maximize the area. And it will minimize the material, which is the perimeter. Okay, and we just proved that by drawing different rectangles, right? Different size rectangles. That gives me a certain perimeter, and we found that the biggest area we just got was the one with a square. So now, basically, we are going to use this from the 2D to apply to the 3D shape. So the purpose of optimizing 3D is to minimize the surface area in this case. Why do I want to minimize the surface area? What do I want to minimize the surface area? And maximize the volume. Why do I want to minimize the surface area? Use less material, that's right, okay? When you're minimizing the surface area, your surface area is the material you're using to make your object, okay? So if I'm looking at this cup, right, it's how much material I'm using to make this cup. Because you are a company, and you're a big company, and you're producing a lot of it, right? Even if you save one little bit, right, times a million, that's a lot of bits, right? So you're trying to minimize the surface area, and you want to maximize the volume. So we talked about 2D shapes, and we said that the square is the one that's going to give me the maximum area and the minimum perimeter. How about when it comes to 3D rectangular prism? What would it be? What shape would maximize, would optimize? A cube. Because cube is made of squares for all faces, right? It's made of squares for the 6 faces. Since the length, width, and height of a cube are all the same, we refer to all of these sides as the letter S. Okay? So, we're thinking about a cube. I can't draw a cube, so I apologize in advance. Okay? So in this case, your length, your width, and your height, they're all the same, and then we're going to refer to them as S. So S times S times S, that gives me the volume of that cube. Okay? So let's look at the formula for the surface area and for the volume. Okay? The volume of a rectangular prism, what's the formula for it? Rectangular prism, what's the formula for it? Length times width times height. Okay? In this case, what would be my length? What would be my width? What would be my height?
Height is S.
S. Length is, and the width is?
S.
So S times S times S gives me S cubed. Okay? This is the formula I'm going to use for my cube.
Nice. Negative 15?
You're 9 below the ground, you go 6 down.
Yeah.
You owe me $9, you owe me 6 more. All right, now let's do this area. Okay? We learned about the nets, and we learned about taking the cube apart and then finding the area of each side and adding them together. Right? So if I have a cube and I take it apart, how many squares would I have? 6, right? So side length, right? So if I look at this square, it's going to have S and S. So what's the area of this? Which is S times S is S squared. I have 6S squared, right? So 6 times S squared, that gives me the area of, or the surface area of the cube, right? Because I have 6, same squares, same area. Make sense? So these are the formulas that you're going to use to find your optimal dimension. Instead of sitting and drawing actually every single cube that may get you to that volume or to that surface area, you're going to use the formulas to solve for your size. Otherwise, it's going to take you days to figure it out. Because right now we're dealing with 3D shapes. It's not as simple as 2D shapes. Okay? So here's the question. The volume of a shoebox is 5,000 centimeter cubed. Calculate the optimal dimension of the prism. So what is given to you? The volume is given to you. If you want to find your optimal dimensions, what would be an optimal dimension? What shape? A cube, right? Now, since the cube is my optimal shape, what is given to me? The volume. So if I'm going to find the dimensions, okay, so the given to me is the volume. So I know that the volume is 5,000 centimeter cubed. I'm looking for the optimal dimension. I know it's a cube, so I'm looking for what letter? S. I don't know what S is. Now, what formula should I start with? What's given to me, though? So why would I start with the surface area formula? So what formula should I start with?
You should start with formula.
So I have two formulas that I'm going to have to pick from. Okay? That's right. So because the volume is given to me, I have to start with the volume formula. Right? I can't just plug in the volume for the surface area. It doesn't make sense. Right? Because the volume is given to me, I'm going to have to use the volume formula. And then what am I going to plug in for the V? 5,000. Now, I'm looking for S. How can I isolate for S? What is it called? Cube root. Because to get rid of a cube, you cube root. Okay? So taking the cube root of both sides, cancels the cube. So what do you get? 17.1 centimeter. Okay? So what would be your optimal dimension to get a 5,000 centimeter cube box?
17.1
by
17.1 by 17.1.
That's right. So the optimal dimension are 17.1 centimeter by 17.1 centimeter by 17.1 centimeter. So how did I solve that problem? What did I do? How did I solve that problem? What did I do?
Get the given.
Write the given down, yeah?
Yeah. Then find the cubic square.
Before I did that, I had to decide what shape I'm using, right? What shape am I using? It doesn't tell me if it's going to be a cube. It says just a rectangular prism, right? So I had to decide that it's a cube, right? giving you the surface area, what do you use?
Number 2, you would use the surface area then.
Because it gives you the surface area. Okay, there's a mistake in number 2. Who can figure it out?
It's not a
be
cube.
optimal for a pizza.
It won't, that's true, but
It's not
let's
a
not
cube.
think about that for now.
It's not a cube.
It's not a cube.
Yeah.
What do you mean, Fab?
Find the dimensions of the optimal pizza box.
Oh, it says surface area, not volume.
It says surface area, and then what does it give me? It gives me the thing in cube. So what should it be?
Squared.
Squared, that's right. So I read this and I say the surface area of a pizza box is 45,000 centimeter cube. No, it should be meter squared because a surface area has a unit of a square. You are right, and that's why sometimes optimizing is not the best way to go.
It's not
Like, I mean, yeah, make a box, like make a cubic box for a pizza is not gonna work because, yeah, I mean, your pizza doesn't have the same height as it has of the length and the width. But, this is the problem, we're gonna have to deal with it as optimizing, okay? It shouldn't say a pizza box. It should say the surface area of, I don't know, tissue box, right? Would make more sense if your tissue box is actually a cube, right? All right, so the surface area of a pizza box, ignore that, is 45,000 centimeters squared. Find the dimension of the optimal pizza box. Your keywords are optimal, okay, and surface area. So what's given to me? So the surface area is 45,000 centimeters squared. And what am I what shape I'm using? Cubic shape. So what am I looking for? No?
S.
S. I'm looking for the side length. What formula I'm going to use?
Then they use the surface area box.
The surface area formula, which is 6s squared. Right? Because the surface area is given to me. So since the surface area is given to me, so that's 45,000 equals 6s squared. Now what I want you to do, guys, is I want you to explain to me how can I isolate for that surface, for that side.
First, you have to find the 6s.
So root the.
And you get 30,000.
I get what you guys are trying to say.
Bring the 6 over to the 45.
Bring the 6 over to the 45,000 first, and how do I bring it when I bring it? What does it become?
Do you divide or does it become a negative?
You divide, it doesn't become negative, right? You want to get rid of that 6, you have to divide by 6, right?
Okay, divide both sides.
To get rid of that. Bedmass, reverse bedmass, right? So reverse bedmass where you don't do the square first. You're gonna have to get rid of that 6 first. So what's 45,000 divided by 6?
Something.
What is it?
7,500.
7,500 equals to the side square. And then
Square root it.
square rooted because you want to get rid of that square. And that gives you, sorry? And that is in centimeters. Okay? So therefore, the optimal dimension, imagine the pizza coming in a square, in a cube. The optimal dimension
If your crust is like
is
86 centimeters.
I know, 86.6 centimeters thick. The optimal dimension is 86.6 centimeter by 86.6 centimeter by 86.6